This video goes over section 4.2 in your notes. This section is over graphing inequalities. You should have completed the teacher talk that talks about which side of the line to shade and whether or not a line is dashed or solid. Alright, so we're going to look at example 1 where we're just graphing these inequalities. So if you remember from lesson 1, part 3, we graphed lines. And in order to graph those lines, we first put them into slope-intercept form, and then we found the slope and the y-intercept from that equation. We're going to do the same thing here. So we're going to start with example 1. And the first thing we want to do is solve this equation for y. I'm going to give myself a little bit more room to write. I'm going to put it over here. Okay, so we want to get y by itself. So remember, look for the thing that's farthest away from y, which in this case would be 2x. And it's positive, so we're going to subtract 2x from both sides. Remember that negative 6 and negative 2x aren't like terms, so we have to keep them separate. And I always put my x part first, followed by my constant. Then all we have to do is get rid of the 3 attached to the y, so that y will be by itself. To undo that 3, I'm going to divide everything by 3. And then the last step is to simplify. We are not dividing by a negative, so the symbol doesn't flip. 2/3 doesn't simplify, but negative 6 over 3 simplifies to negative 2. That's going to be our slope-intercept form of the line. Now, based on our equation, we can see that our slope is negative 2/3 because that's the coefficient on x. And our y-intercept is negative 2 because that's our constant. Look at the symbol. Notice how there's no equal sign. It's just greater than. That means it's going to be a dashed line. How do we know if we're going to shade above or below? I want you to take a look at the symbol. Now hold up both of your hands in front of you. Notice that your left hand kind of looks like a slanted L, whereas your right hand is a backwards L. Your left hand looks like a less than symbol, and your right hand looks like a greater than symbol. Left hand, less than. If you can remember that, that will help you determine what symbol is what. Since it's a greater than symbol, that means that we're going to shade above the boundary line. All right, so let's start at our y-intercept at negative 2. And our slope is negative 2/3. That tells us to go down 2, right 3. I'm going to do that a couple of times. I could also go up 2, left 3. Refer to the video from the last section to help you understand why we go down and right and up and left for a negative slope. It's a dashed line, so I'm going to connect my points using a dashed line. And then we shade above. That means any point in this shaded region is a solution to this graph. Inequalities have multiple solutions, an infinite number of solutions sometimes. So any point in that shaded region would be a solution. This would be a solution, this would be a solution, this would be a solution. However, any point on the line would not be a solution because it is just greater than and not greater than or equal to. Let's take a look at the second example. First thing we have to do is solve for y. Farthest thing away from y is the 3x. It's positive, so I'm going to subtract it from both sides. On the left side, that leaves me with just negative y, greater than or equal to, and then we have the negative 3x and minus 5. Once again, keeping them separate because they aren't like terms. Notice the negative sign in front of the y. That means that y has a coefficient of negative 1. How do I undo negative 1y? They're being multiplied, which means I need to divide everything by negative 1. If you recall, when you divide by a negative, it flips that inequality symbol. Simplifying negative 3 divided by negative 1 gives us 3, and negative 5 divided by negative 1 gives us positive 5. Now we have our slope-intercept form of the line. Our slope is a coefficient on x, so in this case it's 3, and our y-intercept is the constant, so 5. Since our slope is not a fraction, we're going to add a 1 to the denominator to make it a fraction. Our symbol is less than or equal to, which means since that it's equal to, we're going to have a solid line, and since it's less than, we're going to have below. We're going to start at our y-intercept, which is 5, and then use our slope to plot other points. Slope is 3 over 1, which means we're going to go up 3, right 1, or down 3, left 1. And we're going to plot as many points as we can. I'm just continuing to go down 3, left 1. Notice that our line is going uphill from left to right, which is good because we have a positive slope. We want to use a solid line, and we want to shade below. Once again, any point inside that shaded region, so this one right here, this one right here, this one right here, those are all solutions to this inequality. If you plugged in any of their x and y values, you would get a true statement. Also, in this case, the points on the line are true statements because of the equal sign in the inequality.